Okay, so in the last week, we also covered the conversion of this multi-way relationship into binary ones, and I received a question from a student on this conversion. So the question is very long and highlight the main part in the question. It's about conversion. When we convert this purchase relationship into some binary ones, we mentioned we need to add the arrow pointing to the person, the store, and the product. So students have a question about this. I mentioned in my lecture, I say that given a purchase, we can always identify one single product, which is a product of the purchase. And student is confused by this because can it be another purchase with multiple products or not? If so, then we probably don't need to add the arrows, right? So to answer this question, I need to mention more, or I need to clarify more on this to the students. So first of all, let me remind you about the conversion we have. We mentioned this multi-way relationship as shown here, right? We have a person buy some product from a store, and we have this purchase as the action. Of course, we also have an attribute on this purchase. It's a date, right? And we say it is a multi-way relationship, and it is very hard to store this relationship into some tables in our database system, because we prefer the binary relationships. So therefore, we have to do the transform, convert this multi-way relationship into some binary ones. The way we do the conversion is like this. We create one entity for the relationship purchase as shown here, and we create 3 more new relationships as shown here, product of, store of, and buy of. All the person, store, product, they are kept as shown here, and then we connect them together with some lines as shown here. The main part we need to pay attention to is here. We add these arrows pointing to the product, store, and person. The reason we mention in the lecture is that whenever we have a purchase, we can always find one single person, one single store, and one single product. The person buys the product from the store, right? This is what we mentioned. Then the question in your mind will be, if we buy multiple products, can we still do so or not? So in the real world, we can buy multiple products from the store at the same time, right? In one purchase. However, let's assume how can we represent this kind of relationship in our database tables. Let me copy this first. We don't care about this conversion right now. Let's focus on the multi-way relation first. So given a multi-way relation like this, we have entities, we have relationships. It is something related to the next section on the relation model. So because it is beyond the scope of this section, let me briefly mention about this. How can we represent this multi-way relation into the tables? So generally, in the next section, we will mention everything in the ER model needs to be translated into relations. So in the next section on the relation model, we'll mention everything in the ER model need to be transformed or translated into relations. So this relation is something different from relationships. We'll define the concept of relation in the next section. Okay, so everything needs to be translated into relations. For example, we have a person as shown here. This entity should be translated into a relation. We can do the translation very easily. We have a person. It is a relation. So we have to represent this person in a relation, like we have person ID. It will be like a string, something like that, right? So normally in relation, we prefer to use like a var char or char. For example, like 50. The length is 50. And besides this, we will have a person name. It will be all the char, like a 30, and something like that. So the person need to be translated into a relation. Similarly, we can translate the product into a relation as well. So the product will also have a product ID, right? And product name, something like that. Let me copy this product name. Similar for the store. After we do the translation into relations for the entities, it will be easy to store them into some tables, right? We can just create a table for storing the person. It will be very easy, right? Now here we can create a table for the person into a table, something like this. Where the first column denotes the person ID. Let me use a small font. We have a second column denotes the person name, right? And we have some other attributes for the person. And in this table, this is the first column denotes the attribute names, and then inside this we can have concrete examples. Now we have person ID 123, name is John, and some other information we have. Right? So compared with the ER model, it's hard to store the ER model into computers. However, for the relation model, it is very easy for us to store the data we have into tables after we do the translation. Okay, so everything needs to be translated into relations. Then let's come back to the purchase. This is relationship. We also need to translate the relationship, the purchase, into relations as well. Then the question is, how can we do the translation of purchase? Normally, we do the translation by combining the information about purchase. What's the information about purchase? Besides the date we didn't show here, the purchase contains information about the person, about the store, as well as the product. So therefore, if we translate the purchase into a relation, what will be the attributes inside it? The purchase will cover the person ID, right? It indicates the who buy this, who do this purchase. It will cover the store ID, right? As well as the product ID. It indicates what kind of product that the person buys, right? Let me enter a new line here. Again. It also has some other attributes, like we have a date, right? It will be a data structure, something like the date, right? As on a specific date, right? So when we do the translation of a purchase relationship into relations, then the relation we can create for the purchase will be like this. We have person ID, store ID, and product ID as well as date. It will be something like this. Then let's come back to the question asked by the student in the email. So let's assume if we have a person buys multiple products from a store at the same time, then how can we represent this based on the ER model as well as the relation model, right? If we have a person buy this product from the same store, multiple products from the same store on the same date, how can we represent it? We can represent this by storing data into a table, right? So then, based on the purchase relation, we can create a table. Right? The first column will be the person ID. We can clear all the data we have here. The second one will be the store ID, right? The third one will be the product ID. Is ID from there. The last one will be the date, right? So based on the relation purchase, we can create a table for it. It's something like this. We have person ID, the first column, store ID, the second column, product ID, the third column, and date. It is the last column. It should be in a small size. So it's the product as well as store. Right? Then let's assume a person buys multiple products from the same store at the same time. How can we represent it? Let's assume we have a person named John, right? He buys from like some store like CVS on Tennessee Street. He buys some product, for example, he buys some facial mask. On a specific date, let's assume he buys the product on September 5th. We can also indicate a specific time point when he buys this product. Right? It denotes a person buys a product from a store on a specific date. Then the question will be, how can we represent if a person buys multiple products from a store? Because in this column, we can only put one single product ID here. We cannot put a bunch of IDs in the same entry. If a person buys multiple products, what we can do is we have multiple records for the purchase this action. For example, besides the masks, he also buys some other things like we have like sanitizers. And for example, we have some like some medicines. Right? If a person buys multiple products from the same store on the same date, then we can have multiple records in the purchase table, each one with a different like product ID. You can see this, right? Then we need to make it clear. Each row of these records represent one purchase action. The main reason is because in the purchase we have some keys. The key will be a combination of person ID, store ID, and a product ID. If the first three IDs are different, there will be different purchase records, even though they are this item can be bought at the same time. Here for the first records, it is a purchase action. Its ID will be John, CVS on Tennessee Street, and a facial mask. It is one purchase action. The second one will be another purchase action, and third one will be another purchase action. Even though in the real world they are purchased at the same time in the same purchase. However, when we represent them into database tables, there will be different tuples or different records in the tables. So I hope it is clear for you, right? It is correlated with what we have been learned in the following lectures. Then let's come back to the question. The student asks, we mentioned that given a purchase, we can always identify one single product, which is a product of the purchase. And he is confused about because the person may buy multiple products in the same purchase in the real world. So there's a difference between the real world as well as the models we can use for model the real world. Right? In the real world, we can buy multiple products at the same time in the one single purchase. However, when we do modeling in our database systems, we have to define the purchase as a relationship, and we can further translate it into relations and so as to store them into tables. When we do the modeling in the YARN model, we have some changes in the modeling. We say that the purchase will involve one single product. Okay, in this way, then we can do the translation as well as store the data into tables. Therefore, we mentioned given a purchase, we can always identify one single product, which is the product of the purchase. Right? This is one purchase. We can always identify one single product. This is another purchase action. We have a different product. This is another purchase action. We have a different product. Right? Then you may have another question in your mind. For this multi-way relationship, do we need to add one arrow pointing to this product? The answer is still no. If you still remember, we mentioned if we add one arrow pointing to product, it means given a person and a store, we can always identify one single product, which is purchased by the store by the person from the store. However, according to our data, we have given a person as well as the store, actually we can find multiple products purchased by the person, right? And therefore, we don't need to add an error pointing to here. However, when we do the conversion into binary relationships, as shown here, given a purchase, we can always identify one single product, one single store, and one single person. They together will form a purchase relationship in our database systems. Because of this, we have to add these arrows pointing to the product, the store, and the person. I hope it is clear for you right now after we do the clarifications. So we can still do the multiple product purchase in the real world. However, when we do the modeling in our database systems, we will store the purchase as a tuple or as a record, combined with a person ID, store ID, and a product ID as a purchase record in our tables. Therefore, we say, given a purchase, we can always find one single product, which is the product of the purchase. Okay, so this is a clarification for this example we showed in the last class. And let's come back to the subclass